Today we're going to talk about 3D figures, cross-sections, and revolutions. So we're going to look at cross-sections first. Cross-section is the intersection of a plane and a solid figure. And what's a solid figure? A three-dimensional object that has length, width, and height, which is the depth. So in the second part of this, we'll talk about the solid revolution, which is a 3D figure that's formed by rotating a 2D shape around the axis of revolution. And the axis of revolution is a line around which a 2D shape is rotated to create a solid figure. So a cross section can be a single point or a 2D shape. So if we hit at the top of the pyramid, it gives us that point. Or if we have a cross section that's right here in the middle, you can see it makes this 2D shape, which looks rectangular. So it says, name that shape of the cross section formed by a plane passing through the vertex of the cone perpendicular to its base. So you can see this is the shape that we're creating right here with that plane that's crossing through the cone, which makes a triangle. So if we go to here, I can take this plane that we have and I can rotate it so that it is perpendicular to the cone. And once you see when it's rotating, it's creating this triangular shape. So it makes the shape of a triangle. We can also cut the plane so that it's parallel to the base. So when it's parallel to the base, you can see that we are just making similar shapes to the base. And then it hits at the point right here. But we can also rotate this so that it doesn't have to be perpendicular or just parallel. We can also rotate the cone so that it's slanted, right? So if you look here, this gives us what we call an ellipse. It looks oval shape, so an ellipse. And we can keep moving that. So if we make the cross section so that it hits something like this, you can rotate it around. You see that makes a parabola on our cone. So lots of different shapes we can get from our cross sections. So going back to our notes, it says, let's try, name the shape of the cross section formed by the plane perpendicular to the base of the triangular prism. So here you can see the base looks rectangular. So if we were, I'm sorry, the base is triangular, but it's on its side for the prism. So the shape at the bottom part of the side is rectangular. So that gives us this cross section, which is rectangular. But this is a triangular prism, so the base would be the triangle shape. So, because that's what you are taking the bottom of and going all the way up the height. So we go back to our shape here. We have a triangular prism. So here's the triangular prism. And so this would be parallel to the base. It makes a triangle. But when it's perpendicular, you can see that it makes that rectangular shape right there. So it's a rectangle. Draw a cross section of the cylinder that is parallel to the base. So if we had a cross section parallel to the base, if we were cutting it this way with our plane, that would make, as you can see, this circular shape. So this would be the cross section shape right there. So it would be a circle. If we were to draw a cross section of the prism that is parallel to the base, what shape would the cross section be? So the base right here you can see is a hexagon. So if we're making the cross section parallel to the base, it's going to make that same shape. Oops. Hard to draw, but you can see it would make that same shape, which would be another hexagon, because remember hexagons have 6 sides. So let's go back to the cylinder shape. So here I have a cylinder. So parallel, you notice will have the same shape as the base. And if we rotate this, we would get something that's rectangular. But again, when it's parallel, it makes that circular shape. I don't have one that has a hexagon, so you just have to picture it. So it says in a pyramid, excuse me, in a square pyramid, what is the shape of the cross section formed by a plane that is perpendicular to the base of the pyramid and passes through the vertex? So if we are perpendicular passing through the vertex, notice that that's like that first problem that we had with the cone. It's the same idea. It makes that triangular shape, so it makes a triangle. And then it says, what is the shape of the cross section formed by a plane that is parallel to the base of the pyramid? So if it's parallel, and again, remember it said that it's a square pyramid, so that means that this would be right here if it's parallel square. That is similar to the base. So to go back to here, we can look at our pyramid. So here we have a rectangular pyramid, but if this was a square base, you notice that this would be a cross section that's a square. And if it's, again, vertical, then I'm trying to get it to go through the points. There we go. So then if it's vertical, then it would make that triangular shape right there. It says circle all the shapes that are possible cross sections of a cone. So we've already talked about the triangle, and a cone has a circular base, so a circle. And we know we can't make a trapezoid or a rectangle or a square, but we can make a parabola and an ellipse. So again, if I go back to that cone shape, so there's the circle. So anything going this way would make the circle. If we rotate this, so right there, that makes the triangular shape. And if we slant it some so that's not going through the point, we get a parabola. And if we make that so that it's not cutting through the bottom, you can see then that makes the ellipse. All right, if AB is 5, so that's saying that this side is 5 meters and BC is 4 meters and CG is 12 meters. Identify the shape of the cross section BCHE and find its perimeter. So here we have that cross section, which you can see is a rectangle. And so we want to find the perimeter, which means, remember, the outside. So this is H, E, B, and C. And we know that BC is 4 meters. We need to figure out what the length of CH or BE is, because we know those are the same for a rectangle. So to find that, you'll notice that we have this right triangle right here, which we can use, or we can use this right triangle right there. It doesn't matter, they're both the same. So if I draw that triangle, so this would be HGC, we know that since this is 5AB is 5, that means HG is also 5 meters. And then we were told that GC is 12, so we're solving for HC. So since it's a right triangle, we can use the Pythagorean theorem. So HC's length squared is equal to 5 squared plus 12 squared. So 5 squared is 25 and 12 squared is 144. So HC squared equals 169. Take the square root of that. And we don't need the negative answer because it's a distance. So we get HC is equal to 13. So that means this is 13, this is 13, this is also 4. So then the perimeter is equal to 13 plus 13 plus 4 plus 4, which gives us 34 meters. Find the area in terms of pi of the cross-section formed by the plane passing through the center of a sphere with a radius of 6 centimeters. So that means that's going to give us a circular shape. And we know that the area of a circle is equal to pi r squared. And we're using the radius as 6 centimeters. So the area equals pi times 6 squared. So the area equals, it said to leave your answer in terms of pi. So 36 pi centimeters squared, because we're finding the area, not the volume. Next, it says select all true statements about cross sections of 3D figures. So it says a circle is a possible cross section of a pyramid. So if we go back to here, we have a rectangular pyramid here. Now notice that it doesn't matter how I rotate this. No matter what, I am not going to be able to get a circular shape. So here's a triangle pyramid. Again, no matter how I rotate that, it is not going to give me a circular shape, okay? So that first one, we cannot check that one off, but the second one says, all cross sections parallel to the base of a prism are congruent to the base. So if we go back to our shapes, we have a prism. These are pyramids. Remember, pyramids go to the point. So if it's parallel to the base, we're saying that it's congruent. So is that true? It looks to be so. So that means it's equal. Here's the rectangular prism. Parallel plane to the base cutting it. Notice it's equal or congruent. So that one appears to be true. All cross sections parallel to the base of the pyramid are congruent to the base. So now we're talking about a pyramid. So here's a triangular pyramid. So notice that for this one, this is parallel with a cross section, but notice it's not congruent, which means it would be exactly the same. It is similar to the base, but again, it is not congruent. So therefore, that one is not true. So we're not going to check that one off. So we know it's similar. A square is the only possible cross-section shape of a cube. So take a moment to see if you think that's true or not. And then we can go ahead and look at the cross-section for a cube. So here we have a cube. And so the first cross-section, which is either parallel or perpendicular to the base, is going to give us that square shape. But what happens when we change the way that we are tilting or turning this? So if I go this direction, that now gives us a rectangle, right? So now we have a rectangle. We're doing the diagonals that way. And let's see if I can get this to move and turn it some. So if we turn it some, notice we're getting now other shapes. So now we have what appears to look like a hexagon. And again, we can kind of tilt and move that shape around. We can get a triangle shape right there. So again, then we know that that is not true. So we can get lots of shapes, a triangle, a square, rectangle, hexagon, I think a pentagon. And then it says a rectangle is the only possible shape of a cross-section formed by a plane perpendicular to the base of a cylinder. And so that is true. And we looked at that earlier. So if we go back and look at our cylinder, and if it is perpendicular to the base, you can see that it makes that rectangular shape. Okay. Now we are going to move on to our rotations. Any 2D shape can be rotated 360 degrees about a line to create a solid. So take a moment to pause the video. It says to match each 2D shape that's up here with the solid it would form when rotated 360 degrees about line M. So you want to match these to these shapes. So take a minute to pause the video and see if you can do that. Looking at the first one, if we were to rotate this around, if you can imagine doing so. So if we rotated this around, notice that it's going to make that cylinder shape if we rotate this 360 degrees. So same thing over here. If we take this shape and we rotate this 360 degrees, it's going to make a sphere. This one, if we rotate, is going to make the cone shape. And this one, when we rotate it about line M, is going to make this hemisphere shape right there. So it says, name and identify the dimensions of the solid form when the 2D shape is rotated 360 degrees about line M. So before we do that, let's actually go back to here. And I've got some rotations to look at. I got to figure out, I think it's this one. Okay, so here we go. So here's where we had our rectangle. If we rotate that around, notice it makes that cylinder shape. If we make this into a triangle, so you can see then if we rotate it 360 degrees, it makes a cone shape. And let's see, I don't know if we can make any other figures with this, but those are the two that we could take a look at. So I'm going to go back to our notes. So when we rotate this, it says name and identify the dimensions of the solid form when the 2D shape is rotated at 360 degrees about line N. So we know we're going to rotate it this way. And that's going to create this cone shape. So this is a cone. And to find the radius of the cone, we need to figure out what this length is right here from the triangle. So we're going to have to do the Pythagorean theorem. So this is 8 feet, 10 feet, and we want to, oops, I wrote 8 twice. 8 feet, 10 feet, and we want to figure out what this is, which I'm going to call r. So we know that r squared plus 8 squared equals the hypotenuse, which is 10 squared. So we have 100, and we're going to subtract 64 from 100. So we get r squared equals 100 minus 64 would give us 36. So r is equal to 6. So the radius equals 6, and the height is equal to 8 feet. So it says to find the volume of the solid forms, round to the nearest hundredth is necessary. So we know the volume of a cone, because we talked about this the other day, is 1/3 times the base times the height. So the base is circular, so the area of the base is pi r squared times h, which is the height. So we just got to plug in our values. So volume's equal to 1/3 pi times r, which we said was 6 squared, times the height, which you can see the height of this is equal to 8 because it's this distance right here. So then the next step is to just evaluate. So 6 squared is 36 times 8 and divide that by 3. And we get 96 pi cubic feet because remember it's volume, so it's cubed. And if you were to do this in your calculator for the decimal approximation, you could plug that in and you would get 96. And then second in the caret key gives you the pi. So about 301.59 cubic feet. For the next one, it says name and identify the dimensions of the solid form when the 2D shape is rotated 360 degrees about the line K. So if we rotate this around, I'm going to make this go out to 5. So it's going to go like this. So that's how it's going to rotate around. And even though that middle part is there, it's still going to rotate around, but it'll just fill in the other part. So it makes this cone or cone cylinder shape. So for the cylinder shape, we'll be using the longer length as the radius, so that's 5 meters. And then the height was this distance, which is 9 meters. So the radius equals 5 meters. That was feet there. And the height, I'm just going to erase this. And the height's equal to 9 meters. Find the volume of a solid form, round to the nearest hundredth if necessary. So the volume, remember, of a cylinder is the base times the height. So the base is circular, so the area of the base is pi r squared times h, which is just the height. So the volume equals pi times 5 squared times 9. So that volume then gives us 225 pi, and this is cubic meters. And if we want to find the decimal approximation, 225 pi is about 706.86 cubic meters. Oops, I guess we don't need all of that. The next one says a square with a side length of 2 inches is rotated 360 degrees about its edge. Name and sketch a picture of the solid form by the rotation. Label the known dimensions in your picture. So however you want to rotate this. So we have a square. And this is 2 inches by 2 inches. So if we rotate this around, we note that it's going to make the shape of a cylinder. Trying to draw it about as equal as I can get it. So this is 2 inches, and this is also supposed to be 2 inches. I should have maybe made that shorter. There we go. So this is a cylinder with a radius of 2 inches and height of 2 inches. What is the least number of degrees circle H could be rotated about line K to form a sphere? So since this is a full circle, if we rotate this 180 degrees, we would make a sphere. And then it says to find the volume in terms of pi of the sphere. So the volume in terms of pi, we first need to figure out the radius, which we can see from this picture is 3 millimeters. So the volume equals 4/3 pi times 3 cubed. And so if we were to multiply this out, 3 cubed is 27, or if you don't know, you can plug it into your calculator. So, and then we're going to multiply that by 4 and divide that by 3 to get 36 pi. So notice I did everything without the pi in it to get the exact answer first. So 36 pi cubic millimeters would be the exact answer. So then 36 divided by, or not divided by, multiplied by pi gives us about 113. And then if we round, we get 0.10 millimeters cubed, or cubic millimeters. The next one says, select all solids that could be generated by rotating a 2D figure up 360 degrees about a line. So a hemisphere would be possible. So to get the hemisphere, if we rotated something that looked like this 360 degrees, that would give us our hemisphere, or you could rotate it about the other one as well and still get it. A cylinder, of course, we know is possible because we've been doing that with our rectangles. This would be a better picture for that first one. So for a cylinder, let's say this was our line, we could rotate this square. A cube is not possible because if you think about rotating a square, it gives you a cylinder. Rectangular prism is not possible. We know a cone is possible with a triangle. We've been doing those. A square pyramid is not possible. A parabola is also not possible. A sphere we know is possible. So if we rotate this figure around 360, that would give us a sphere. A circle is not possible, and neither is a triangular prism. So the next one says to draw and label a 2D figure and line of rotation that would generate a cone with a height of 7 meters and a diameter of 8 meters when rotated 360 degrees. So let's call this line L. So if we were to rotate this triangle, and if the diameter is 8 meters, that means this would be 4 meters, and this would be 7 meters. So if we were to rotate that 360 degrees about this line, that would generate the cone with, again, a height of 7 meters and a radius of 4 meters. Select all true statements about rotating 2D figures. A right triangle rotated 360 degrees about its hypotenuse forms a square pyramid. So that is not true. A circle rotated 180 degrees about its diameter forms a sphere. So that's true. A rectangle rotated 360 degrees about the edge forms a cylinder. That's true. A right triangle rotated 360 degrees about its leg forms a cone. True. A circle rotated 180 degrees about its diameter forms a cylinder. So that is not true. We just talked about it making a sphere. A rectangle rotated 180 degrees about its diagonal forms a rectangular prism. Not true. A cylinder could be formed by rotating a circle 360 degrees about its edge, which is not true. So just to show you, I do have a picture of that. Let's see if I can get it up. So if we have a circle, and I can't move this up or down, but just pretend like we're rotating it about its edge on this blue line right here. So if I rotate that around, this is the shape that we're getting, which kind of looks like a donut shape. It's actually called a torus. So we do a lot with that in calculus. But again, you'll notice that it does not form a cylinder shape. So just kind of keep that in mind. If we make the radius smaller, move it over, you can see that torus shape. So if we move it over, it makes more of a circular shape. So if it's in the center, you can see it makes that sphere. All right. A cone could be formed by rotating any right triangle 360 about its leg, which is true. Because again, remember, if I have this right here, and if I rotate this around, that's just going to make, again, that's cone shape. So that is it for cross sections and rotations.